Good afternoon, Tom. Thanks for this interview today. It's always an honor. Today we'll be talking about scientists, a subject you are certainly qualified to discuss. What is a real scientist? What are the characteristics and the attributes, in your opinion?
Okay, well, science is about discovery. Science is about finding out what, the reasons why things are the way they are. And often there's multiple models about how things are, and then we tend to take the model that is the simplest and most straightforward. But there are a few attributes of science that are worth mentioning, and one is that a scientist is somebody who has great reverence and respect for the truth. They do what they have to do the research, spend the time, and often that's not an easy thing to do. They kind of dedicate themselves to discovering truth, how things work, why things are the way they are. Now, as time goes by, many physicists, kind of what I call the center, many physicists at the center, they begin to forget that science is about, one, you find something that you don't understand. You find an anomaly, something that lies outside of what we know now, what we can explain. It's not covered by the models that we presently have, or it's a piece of data that contradicts the models that we already have. And that, to a scientist, is what's interesting. The stuff that falls inside the models, yeah, okay, we sort of know that, we've got that covered, but now here's a piece of data that conflicts with the model, contradicts the model. Then the first thing a real scientist will do is say, is that contradiction true? Is that really a contradiction, or are we just misunderstanding or reading the data wrong, or having just a one-time anomalous event, a random fluctuation? So the real scientist then wants to take data, wants to discover whether or not that anomaly is really a fundamental anomaly, is really something that contradicts the current model, the status quo model. And if they come to the conclusion that, yes, there's really something going on here, it's not just some happenstance, random fluctuation event, but there's really something going on here that contradicts the model, then a scientist will want to study that. They'll want to find out, how can we expand the model to take in this new information? Because if you have something that contradicts the model, you determine that that's a real anomaly, it's not just a random event, then the logical conclusion is the model's incomplete. There are things that the model, doesn't contain, doesn't explain. So the model will have to be either replaced with a better one or expanded to meet the new data. And that's what scientists do. They look for anomalies, things that don't fit the present understanding. Then they research those to make sure they're real anomalies, there's real conflict there. And then they try to expand the models that they have, or replace the models that they have with something bigger and better that will not only describe the old information, but also describe and explain the new information too. That's how science grows, how it improves itself. It keeps getting a bigger and bigger, a more inclusive view of the phenomena we find in the world. Okay, so that's what scientists do. That's the whole thing about science. So if we want to look at the scientific method and we see where does that fit in, well, first you start with a hypothesis, right? And that's the scientist who has found an anomaly or something that you don't understand why it should be that way. And you have a hypothesis about how it might work, some idea. And if you don't have that, some things maybe you just don't have any idea. Look at this. It's an odd thing. I have no idea why that works, but you can start to study it, start to eliminate variables so that you can determine how it works. And then maybe you come up with a hypothesis. And then you go out and do research, collect data, information, experience, and at the end of that, you either prove or disprove your hypothesis, but you also come to some understanding of the phenomena itself, and hopefully, if you're successful, why it's working, why it's like that. What are we really seeing? That would be kind of a success of science. A lot of times science gets to an anomaly and they just still don't know. They don't understand why it's like that. So science admits to things that they don't know, or real science. We're talking about real science because there's a lot of things called science that aren't really science. They're something else. And real science admits to things that it doesn't know. It said, well, yeah, these things happen, but I can't explain them. Okay? Now, that is different than a lot of the science that we practice today. Things that are called science and people that call themselves scientists. Eventually, it becomes, people are so, they're so sure of their models. They feel so like they know almost everything. You know, and we hear this all the time. Listen to the scientists at the end of the 1800s, and you'll hear them saying, almost everything's been discovered. You know, listen to the scientists at the end of the 1700s, and they'll say, almost everything's been discovered now. There's just a little bit we don't know. And scientists tend to feel that way. People tend to feel that way. And the reason they feel that way is because they don't know what they don't know. Well, that's kind of obvious. That's called tautology. When you don't know what you don't know, yes, that's obviously true. But you don't realize how ignorant you are. You don't realize how much there is out there that you just don't have any idea about. And because we're not aware of what we don't know, we believe that we know almost everything. And that if it's outside of what we know, then it couldn't possibly be true because we know almost everything. So, you know, it's like it's an assumption of omniscience. We have this unfortunate tendency in the human race to have this assumption of omniscience. We believe we know almost everything, and anything outside of what we already know is very tiny and probably not all that significant. Whereas what we're calling a real scientist shouldn't feel that way. A real scientist would say, there's lots of things that we don't know. We've barely scratched the surface of what can be known. And I want to look for all those things that are anomaly, that, you know, kind of stick out as conflicts and things that just don't fit in the theories, because that's where the real science is going to be done. So we have those working on the edge, those working on the fringe, at the borders of science, trying to understand anomalous data, trying to understand things that happen that nobody has an explanation for. That's what I call real science. And then we have the great majority who are basically picking apart the logical consequences in the detail. You know, they're like miners, you know, in a mine, and they're digging and digging, and they'll find a little nugget, something that we didn't know. Oh, in the shell model of the nucleus back in whatever, it's predicted that there might be a spin state of a certain type, of a certain element, you know, in a certain way, and it could be, you know, what's the back value? We've narrowed that down to the answer is within plus or minus these, but I can do an experiment and I'll narrow that to a more precise value. And that's the kind of science that is mostly done in the universities and, you know, all over. They are learning new things, they are finding new knowledge, but they're more and more precisely digging out logical consequences of reality. That is not the science, you know, that is not That's a different kind of science, really, than what I've been talking about, as the real science. I would call that sort of science where you're just picking out logical details out of what's known. You're making finer and finer measurements. You're looking for the Higgs boson. And the Higgs boson is a tiny little resonance, energetic resonance, where if you look at billions and billions and billions of collisions, once every, 10 billion times, you get this tiny little thing out, and that's what we're looking for. And that was a really big deal because it helps fill in this standard model, because there's a blank here where a Higgs boson, or what they called the Higgs boson, ought to be. So we sift through all this data, and we take billions of collisions, and we find this tiny little minute resonance, and that's a great, that's a really great find. But the significance of that is really not that much. Now, we give it a bigger significance in the fact that we say, well, that's the Higgs boson gives us mass. But that's more hand-waving argument than that is actual fact. How does it do that? And then there's models. Well, it's sort of like a viscous fluid, it produces mass because it produces, resistance moving through this fluid. And we have these kind of arguments trying to explain it in words of what's going on, but they fall really, really flat. Mass isn't just about inertia. That's a property of mass, but that's not all there is to mass. And besides, it's a very far-fetched kind of logic that makes those sorts of connections. But anyway, that's a science of picking out detail, making finer measurements, reading, if we've already got the lines, then let's try to read between the lines. Let's get more and more detail. It's a mining operation. That kind of science is almost, scientists now will, they'll chafe, they'll choke on this. Sorry guys, but that kind of science is almost under the description of technician, scientific technician. When we talk about science in the way I'm talking about it, it's breakthrough. We're talking about new ideas. And it's not that what I'm calling, kind of technician, or instead of scientists, that they act more like technicians. I don't mean that in a belittling way. That's important. That's valid. You do need to dig out all these nuggets. So there's not something wrong with that. But that's not the same kind of science that we mean when we talk about discovering new paradigms, new ways of thinking. That science is a riskier, bolder thing, and it sometimes falls flat on its face. Sometimes you think you have a new paradigm and a new way of seeing it, and you find out it was just a bias in your data, you see, and then you look a little foolish, you see. So there's risk to that. It's not a good career field to be out on the fringe looking for new things, because you might look for a long time and not find anything. You might be like Albert Einstein and spend the last 20, 25 years working on a unified field theory, and at the end, you don't have a unified field theory. You just never succeed. So those that are looking for new things, new understandings, taking the anomalies that we have, the conflicts that we have, and trying to understand them, that's where I think that's what I'm describing as the real science. That's what real scientists ought to be doing. And this other stuff, yes, that's science too, but it's kind of the drone work of science, if you will. It's the work that needs to be done, but it's the shovel and pick, everyday work of science to dig out these details. And there's a little difference between there. Well, what happens is that we make careers of science. We scientists, have careers just like everybody else, and we have to produce just like everybody else. And saying that all the 10 million scientists that there are all have to come with a great breakthrough isn't going to work. There aren't going to have 10 million breakthroughs this year, and that's how many scientists there are in the world, that sort of thing. It just isn't going to happen, obviously. You're going to get big breakthroughs maybe in a decade, maybe a couple of them, in a decade, maybe, half a dozen of them, in a century. They're not the kind of things that you can make a career on. They're the kinds of things that seem to happen. The right person at the right time gets the right idea, and they work on it, and boom, you have a breakthrough, like an Einstein, Bohr, Heisenberg. Those guys were doing breakthrough work back in the early 1900s. But that doesn't happen all the time. But then what happens is that the scientists kind of get into this career line of the technical work, the technician's work of digging out the details. And that becomes our new definition of science, and this idea that you're going to go produce some kind of major new viewpoint is seen as kind of quirky. Who would want to do that? That's a career killer, not a career builder. If you just mine this vein of nuclear physics, or mine this vein of atomic physics, or mine this vein of quantum mechanics, you can dig and dig and dig, and every once in a while you'll find a gem, and you can write papers, and everybody can read each other's papers, and then you get citations, and this is career physics. But it's safe as far as a career goes. It's hard work, it's important work, but it's safe work. So that's why, we ask the question, well, why isn't science all over these new things? There's lots of data that shows anomalies happening in the world. It's there. Well, what happens is that the mainstream science, which is maybe a better word than calling them technicians, let's just call them mainstream science, that the mainstream science kind of doesn't go there. We have PEAR Labs, who for decades have been showing intent modifies the result of random processes. And they can show that to 1,000,000,001 statistical significance. But they can't even get papers published, and they are a science house associated with Princeton University that is basically shunned in the traditional or mainstream science world, because that's not what mainstream science does. And the mainstream science doesn't really want to deal with those things. They ignore them, and that ignoring them, because it's not good career, turns into denial. Because then they're saying, well, our models have holes in them. There's these things that conflict with our models. What are we going to do? Well, if we were good scientists, we'd go study that conflict and try to increase our model. Well, that's not something that's likely to pay off. So what we do is deny that there is a conflict. We say, oh, those guys at PEAR Labs, it's just measurement error, they don't have good methods, or, oh, the results are very small. We make up something to marginalize what they're doing, and we can pretend that we can just forget about it like it doesn't exist, and our models are fine and go on. So that's kind of this problem with science. We're kind of discussing science and what are the problems. The problems is that the mainstream is comfortable where it is. They don't want to find major flaws in their models of reality and the way things work, because they're very comfortable mining out details within these models. That would kind of tear the ground up underneath everybody, you see. And science is a business, like any other business. It's a career, and the careerists are happy, pick and shovel, mining out new facts, little nuggets of things that they can get excited about. So that's why when you have research, like the research that Brian Weiss does, we'll talk about that a little bit, or the research that Targ does, Russell Targ, You know, the research, and that's in remote viewing. He did a lot of research in remote viewing, and Brian Weiss did the research in past lives, kind of reincarnational things. And there's these other anomalies. You know, you go back, what, 30 years, 40 years, and you find at Duke University, a major university, B Rhine Institute at Duke University, you know, he showed that there are anomalies in our model of reality. There are people who can, way above chance, you know, tell you things that they should have no knowledge of. Like, I've got 5 symbols on this, you know, I've got 5 or 6 symbols that I have in a deck of cards here that are all randomly shuffled, and I pull one out and I want that person to tell me, what is it? A circle, a square, you know, a line, whatever. And you would expect it would be random, right? How would they know? They would just guess. Well, Rhine found people, some people could kind of train themselves to consistently get the right answers to a level that exceeded what should have been, you know, what was likely. Okay, maybe it was just dumb luck once, but how do you have dumb luck, you know, 80% of the times that you try? Now that tells you that there's something statistically significant going on, and he had lots of experiments that were statistically significant. Well, that was, yeah, probably 40 years ago, you know, a long time. It's not like this is just kind of new data that we've never had before. The remote viewing, there's been lots of science done, very good experiments, meticulous protocols, you know, triple blind protocols. And the remote viewers do very, very well. They get the information that is judged when you look at what's their targets and what do they get. They're really getting this information, and they're not getting it through normal means. What's that mean? It means there's an anomaly. The normal means it's understandable by our models. Our models say that's impossible. Their models say that what B Rhine did was impossible. You see? So what does that mean? That doesn't mean that they're all wrong because it's impossible that our model couldn't be perfect. You see? That's not science. That's religion. That's belief. Our models are good. If you get something that, you know, is contradictory to our model, then you must be wrong. That's not science at all. That's you know, that's belief. That's something else again. So that's kind of a thumbnail view of science and where it is. We have this the mass of scientists that fit in the middle. You know, that's the center of the science world. And the center of the science world does a couple of things well. They take a model and they work out its logical consequences. They mine nuggets of understanding that we didn't have before that now we have because of their work. That's the center. The center provides infrastructure. It provides universities, it provides libraries, it provides equipment, it provides ways that young people can grow up to become scientists. You know, it's what you need to even maintain, you know, a scientific outlook in a culture and a society. So it's a very important thing. It's not like you could get rid of that. You need that. But that's not where, in my estimation, what I'm calling the real science is done. That's not where the breakthrough comes from. That's not where the people who think out of the box, look for those anomalies, and try to understand them. That's the science that really moves us forwards. That's where we get new ideas and new concepts. That's the role of science as I see it. You know, that's a Galileo, that's a Copernicus, you know, that's a Newton, that's an Einstein. You know, these are the people that say, yeah, I know, you know, this is counter to the status quo in science, but here it is, and here are the anomalies, and here's what here's what I think could explain them. That takes courage, and it's not a, there's not many careers that require courage. Most careers require stick-to-itiveness. They require conformity. They require, helping maintain the status quo. That's generally what careers are about in any field, whether it's, the arts or anything else. It's careers that are successful, in other words, that pay the bills, tend to be safe, thing you can rely on, because you have to rely on those bills being paid. You need those to be paid all the time. So they don't require a lot of courage to be a scientist in the middle. To be a scientist out on the edge does require courage, because the middle will immediately tell you that you're wrong because you disagree with, you disagree with the old model, with the models we have now. You don't support the status quo. You're rocking the boat. You're saying that what you guys are working on really isn't the big picture, and it's not a career enhancer at all. So only the mavericks, only those that have the courage to go off and dig out truth wherever they find it, and then talk about it and publish about it and bring it to the fore, those are the people I admire in science. Yes, we need all those guys with their picks and shovels, digging out the nuggets that we need to know. It's not there's anything wrong with that. We need those guys, but that's not where the action is in science. The real action in science, the real scientists are the ones looking for something new, looking for explanations for this anomalous data, like the data in PEAR Labs. How is it that people can use their intent and modify random events? How is that? And just turning a blind eye and saying, we don't want to hear about it, it must be wrong, couldn't possibly be right because it violates, our theory. That's religion. Scientific religion, if you like, that's, maybe I shouldn't call it religion. That's just belief. And it's closed-minded, and it's pretty empty as far as discovery goes.
I know you're familiar with Thomas Kuhn's book, The Structure of Scientific Revolutions. What was this? This was written first in 1962. What was his message there? Is it similar to
Well,
what
he's written
saying?
it in 62. He's republished it a couple of times. I think the last time was like in 2012. 2011, 2012 is when he's put it back out, added some things to it, whatever. But his thesis, and the interesting thing is that when he wrote this, it was heralded as kind of a breakthrough in the philosophy of science. It was a big deal, and it was acclaimed, and was like, wow, we've never had any idea it could be this way. And what he basically said is just what we've said. He said that historically, if you look at the history of science, you will find that the breakthrough, the big ideas, the understandings that have changed things, that have kind of raised science up to a higher level, none of them, well, I shouldn't say none of them, the vast majority of them come from out on the fringe of science. They come from outside of mainstream science. It's not that mainstream science figures out things and we get smarter and smarter and smarter as the mainstream uncovers more and more facts. That is not the way it works. The mainstream is plugging and chugging away, mining out details out of their model, and the big science, the breakthroughs, what I'm calling the real science that scientists should be focused on, that has always come from outside. It's not the mainstream scientists, physicists, chemists, biologists that come up with innovative things that kind of vault science forward in their understanding. These great leaps forward always comes from outside the mainstream. At least that's where most of them come from. Well, that's what Kuhn said. He said that it's the fringe It's the scientific fringe is where the big ideas come from. The important ideas come from, not from the middle. And evidently there was a belief, as there is today, that that's not true, that it's the middle, it's these technicians in the middle that keep digging out more and more of these nuggets, that these nuggets somehow all go together and make us smarter and present us with big breakthroughs and so on. And that's not the case. That's not the normal case. Typically, it's not that way at all. Somebody comes from outside of the fraternity of scientists. Somebody comes from the edges, from the fringe, with a big idea, and eventually it totally revolutionizes our viewpoint in science. And that was Kuhn's major contribution, to look back through history and say that it's always been this way, and it'll probably always be this way, because people who are mining in the status quo of ideas are not likely to come up with anything very creative, very original, or important in the big picture. They come up with things that are very important in the little picture, but they're not moving science as a whole. So we shouldn't look to the center for answers, and we shouldn't actually pay a lot of attention to the center when they talk about the fringe, because the center, that's not their thing, you see. So when the center looks out at the fringe, when they look out at the PEAR Labs and say, oh, those guys don't know anything, they must be making mistakes. We don't know what their mistakes are, but obviously they're mistakes because what they have shown or what they're doing just isn't right. It couldn't be that way, so there has to be a mistake. We should discount most of that, because the center that's not what they do, you see. That's not where their value is. It's like, go back and plug and chug some more on your details, and don't feel like defending the status quo is kind of the noble scientific thing to do, because defending the status quo is really anti-science, in a sense that it even makes it more difficult for the scientists out on the fringe, what I call the real scientists out on the fringe, to work and discover and find new and big ideas, because the center is so hostile to change, so hostile to their models being shown to be insufficient.
Well, we're fortunate today that we have so many scientists that have contributed so much to our understanding of life in the larger reality. I know you call these the real scientists. They come from diverse fields, as you mentioned, Russell Targ in remote viewing, there's Dr. Bruce Lipton in cellular biology, there's Brian Weiss in past life therapy. Now these are all people highly credentialed, impeccable credentials, who started off in one field and discovered things. Their courage and their open-mindedness, their willingness to pursue information, sometimes sought after information, sometimes it was thrust upon them. And they had the courage to stop and evaluate which direction they wanted to go in with this. Did they want to retreat and be safe in their careers, or did they want to pursue this new information and this discovery? And many of them, fortunately, decided to take that anomaly they found. For instance, Brian Weiss discovered through one of his patients, past lives are real. This was a part of a therapy he was doing with one of his patients, and he discovered that there was no explanation other than this must be a past life memory that helped this woman out of these phobias she was having. Now, it took a lot of courage to recognize what it was and to pursue it that way for the sake of his profession, psychiatry.
Sure. Yeah, what he actually realized, I wouldn't make so bold a statement as to say he realized that past lives were real. He probably didn't go there yet, because I think the way you'd say it is that he realized that past life was a good metaphor or a good way to help his patients. You see, it was effective. So we start with this metaphor of past lives. He had a patient, and he was using, I guess, hypnosis or something to help this patient get to the source of a problem. And the patient starts describing the problem, but that obviously wasn't in this lifetime. It's like, where is this patient coming from? You know, they're describing a totally different situation that isn't real. But he worked with it. He didn't say, oh, that was just imagination. Forget that. You know, let's do something real. See, that's where it took the courage. He has a patient. He goes with it. He lets this, and it helps the patient. The patient gets over the problem. So now he's found out that this past life, whatever that was, we'll just call it a metaphor right now, actually works. His patient got better. So then he starts thinking, well, maybe I can use this with other patients. It seemed to be an effective thing for this patient. And sure enough, he finds out he can regress people back beyond their birth, back into, quote, metaphor, a past life. And it's a good therapy. It's effective, you see. Now, if you're a scientist, if you're a real scientist, you can't not follow the truth. This was a good, effective therapy. You can't say, yeah, but it's a little weird, so I don't want to go there because I don't want the rest of my peers to laugh at me, so we're just going to forget about this. That's not a good place to go. That's what what do we call it? The mainstream might think that way. But a real scientist says, I'm finding something that's working here. I'm finding something that's valuable to my patients. I'm going to pursue it. So he starts working with this past life metaphor and collects more and more data. Now he's seen maybe hundreds of patients that he's done this to. He has a good sense of, how it works. And he's also running across patients that have past life experiences that are evidential. Things that he can then find out about. And there's other books written about that as well, where a past life person says, oh, I was such and such in this place and I did this. And you can go back, and sometimes there's history books written that'll actually talk to that event and that place and whether that happened, and it verifies, you see. So now he's getting more and more data. And now this metaphor is starting to sound like it's maybe a little more than just a metaphor. Maybe this, it's starting to sound like there's maybe something actual to that. Well, I suspect Brian Weiss doesn't really know how that might happen. He just knows that it works. And there's historical confirmation some of the time. Sometimes there's nothing in history written about that event, so you can't get confirmation. Sometimes you can. But you see, you only have to get confirmation once, just real good solid confirmation once, to know that there's something real going on there. You don't have to get it from everybody because everybody's different. But if you get one exception proves that the exception is not impossible, that the exception is a real thing. And of course, you'd have to also show that the person, this wasn't stuff in their own mind. This would have been information that they could not possibly have had access to in any way, or guessed at, or so on. So anyway, he has enough experience that he starts to realize that there's more to it than just a metaphor. But he can't go much further than that the past life is kind of a metaphor for ways of seeing phenomena that have affected people now, and if you can deal with it in that context, the patients can get better. So he sees it in the context of a tool. But he can't really go too far beyond that because he doesn't have an underlying structure. He doesn't have a context in which to define what's going on. What's really happening there? What is a past life? What does that mean? Okay, it makes a good metaphor here, but what's behind that metaphor? Is there something more concrete to it? And without a good context, then there's not too much you can make of it. Well, of course, in our culture, people have been talking about past lives, and you have mediums that talk to the dead, and you have you go to Eastern cultures where reincarnation is an accepted theological proposition. Everybody accepts that, of course, is the way it is, but not in our culture. So you have these other things that kind of give some support, some realistic support to what's going on, some kind of flesh out that metaphor with a little more concreteness, but there's still no underlying, quote, scientific foundation underneath of it to which to give context to this tool that he's created. So that's really the problem, and it's been the problem with all these people. Same with PEAR Labs. PEAR Labs, they use intent to modify random distributions. Well, that's from the center, that's impossible. From in the fringe, where the real science is done, that's a fact. It's not only possible, it's a fact. They've done it, thousands of times to statistical significance. So they've got this fact. But what keeps them from really going very much further with it, what are they going to do with this fact? Well, they don't have any underlying theory to place that fact within the context of how the world works. All right, here's how the world works. Here's this bigger theory of how the world works, and of course there's your fact. Your fact plugs in right there. That's why people are able to modify statistical distributions. It's because of this, you see. And Weiss needs a theory that says, well, here's why those past lives, are relevant to this life, and what the connection is, and why kind of healing it in the past heals it in the future, and so on. Here's how that works. That just plugs in here to this larger theory. Until you have the bigger theory that explains why these things are that way, then it's just an anomaly. Yeah, I've got this anomaly. I can deal with people's past lives and it helps them get better. And I'm a therapist, I'm a psychiatrist, and it makes my work, it's significant to my work. It's a tool that I can use. And same with the PEAR Labs. They don't know, but if all they can say is, we have no idea why it works. We just know that it does.
Well, that's where your My Big Toe comes in.
Yeah.
And the interesting thing about Brian Weiss, too, Columbia University, Yale Medical School, had no intention of going down this road, but the reason that I think it's interesting what he's doing and so courageous, he's also tapped into his own past lives. So he's made that experience, which you say is one of the most important things, your own experience, he made that experience his own. He's pursued his own past in order to understand a little bit more about what's going on. So that was quite interesting too. And not only himself, but Michael Newton at the Newton Institute for Life Between Lives. There's a lot of work done there.
Yeah, he does similar things, right? It's hypnotic regression of people beyond the start of their lifetime.
And also Helen Wambach, this is back in the 60s, she gathered information and data to support population and gender distribution of the time she was regressing patients to. She looked at it at from another angle, more than therapist, but more as a psychologist, a PhD in psychology. She also discovered and experienced spontaneously a past life, but she went on to try to put these things within a scientific framework. And I think had she had the My Big Toe theory to plug into, it would have been a lot more clear, a lot simpler for her to see that.
Yeah, everything would make sense, because then you'd put it in the context of something bigger. If it's just in the context of itself, it's like, well, this is a tool, or yes, this is a fact that happens at PEAR Labs, or yes, my data shows this, but I really don't have any way to, work that into a larger logical context, then you're kind of stuck there. And it's easier for people to kind of blow it off and not pay much attention to it, because it's not in some larger logical context. It's not part of a bigger science. So that's true. But you have these people, and you might ask, well, why do these people do this? Very highly credentialed people doing great in their standard, midstream, what do we call it? They're in the center, of their professions, doing very acceptable work. It's a good career. So why do they go out and start doing things like Brian Weiss, or this lady who writes the book about researching experiences in past lives and then looking for evidence to show that this actually indeed did happen? They do it because they are real scientists, and real scientists can make no other choice. Once they've found something that's significant, secondly, they found that significant thing is real. It's not part of their imagination. It's not a statistical fluctuation. It wasn't a lucky guess that there's something here that's actually real. Then, if they're real scientists, they can't avoid the next step, which is to go farther, collect the data, do the research, and discover, what is this about? How real is it in the sense? Is it just this one person? Is that it? Or does everybody do this? And to what extent? And how far back? And what are the parameters? They want to know these things. And a real scientist won't rest until they do what they can to dig that out. That's the nature of science. That's the nature. What made Galileo, come up with things that he knew flew in the face of, the tradition of his day, flew in the face of what was believed to be true? Well, it takes courage. To be a scientist it takes courage. You have to stand outside the mob. You have to be a nonconformist. You have to be willing to let your peers laugh at you. You have to pursue truth as you find it. And many of these areas, you're talking about psychiatrists, psychologists, well, of course with Russell Targ, you're talking about physicists. But in these cases, much of it is done in an area that is more, or at least has large components of being subjective rather than objective, you see, which is a taboo, in the science idea. Oh, science is only about the objective world. Well, the problem is the objective world is only a small part of our reality. You see, what we do, or the decisions we make and the reasons we make them, what really is important in our lives is not the objective world, it's the inside world. It's our thoughts, our feelings, our knowledge, our experience. All of these things are very important to us in our reality. Just the stuff, the rocks and the trees and the furniture and the houses and the metals and all the stuff out there, well, yeah, that's significant. We build our house of them, and I'm sitting on one of them. We have lights here and cameras running, and all of the stuff is significant, but it's not the only thing in our lives that are significant. All of our choices, every choice we make in life, is a subjective choice. We make it based on our subjective knowledge and understanding of the world. So this area of subjective interpretation is immense. And if anybody sits down and looks at themselves and said, what's important in my life? What's the really core, the important things in my life? They will not name the objective things. They won't say, well, what's important in my life is my house and my car and the street that I drive on and, all these things, that's what's important in my life. That's just not true. They have a very empty life. What's important in their life are their significant other, their children, their caring, their love, their interaction. That's what's important in their life. You know, there's some old saying that says there's nobody that's been on their deathbed and their last words were, "I wish I would have worked more." I wish I would have had more stuff, you know. Nobody feels like that. When it gets down to what is important and what do you wish about your life, it's which I would have loved more. I wish I would have connected more with people. I wish I, wouldn't have been so self-centered. I wish I would have expanded and been. I wish I would have traveled more. I wish I would have seen and experienced more. You'll hear that, but I wish I would have worked more. I wish I would have earned more money. And I wish I had a newer car. I wish my house were bigger. None of that is really very important to people, but that's all the objective stuff. So the objective world is a very small and the least significant part of anybody's life. So many of these things are subjective. The lady who said, "Oh, I see myself now and I'm in a different place and surrounded by different people and this is going on and that's a past life." That's how we interpret that as a past life. That's the metaphor. That's all subjective, you see. But just because it's subjective doesn't mean it isn't important. Doesn't mean that it isn't tied to this disability that she has now. Doesn't mean it isn't, significant. We have to realize that there's a lot of things, mostly important things, that are not objective. They are subjective. And then when we start to scrutinize this objective world, we find out that there really is no objective world. We get data and information and we have to interpret it as to what we see, what's there. We interpret this objective world. You see, we get sense data. We interpret that data. Well, our interpretation is not objective. Our interpretation is based on our experience, our knowledge, our fear, our hopes. That's how we interpret it. That's why the 5 people who see the accident from the same street corner put in 5 totally different accident reports, because each one interprets it differently. So this objective world that we keep thinking is the real world, the important world, it's not only mostly insignificant compared to the subjective world, but it's not really even objective. It's interpreted. Everybody sees it differently. Every one of us is walking around in our own reality that is a little bit different than everybody else's reality. Everybody will look at the same painting, but they see different things in it. It means different things to them. Everybody looks at the same accident and they see different things in it, and it means different things to them. So where is this objective world? You see? Well, yes, we're in a multiplayer game, so we both agree that I'm sitting in a chair and the chair is made, has wooden arms and cloth and the colors, and we can do that. And we say that's objective. But I don't see the same color you see. We both say it's kind of yellowish, it's white to the yellow side or something like that. But those are very vague terms. We kind of agree in vague ways, but if it got down to specifics, how do you know that your blue is the same as my blue? Blue is not a fact. Blue is an interpretation. Well, this chair is an interpretation. All right, we agree, everybody agrees it has a high back, it's got wooden arms, but the details we don't agree on. What we remember we don't agree on. What we take away from it, what is meaningful to us we don't agree on. Okay? So yes, we could measure it. We could get a bunch of scientists out here to measure exactly how much it weighed, exactly what it was, take pictures of it from every angle. But still, though we'd have all the measurement data, anybody who walked in the room and looked at it would get something just a little different, because they'd see it. Their sense data would have to be interpreted according to their knowledge, their experience, and the rest of it, and what that chair meant to them, how they interpreted it, what it was in their reality would be a little slightly different. Nobody would exactly see all the details that the scientists would measure about the chair. You see, that would be another view of it. So we don't really live in an objective world. We live in a subjective world But there's this, what we call objective is just less uncertain. What we call objective has a small uncertainty about it. All right, everybody sees this chair differently, but the differences are just small. The uncertainty is small, but the uncertainty is there. Now, when you talk about your, things inside your head, what everybody calls subjective, your attitudes, your beliefs, the way you feel about things, all that is subjective. Well, there's a much bigger uncertainty around that. You and the person standing next to you don't necessarily feel the same way about this chair, or feel the same way about that accident, or interpret what was going on the same way. You see, but that's because there's more uncertainty there. So that's all. We live in a world that's totally subjective. Some parts of it have more or less uncertainty than the others. You see, that's a bigger view. We don't live in a objective world and a subjective world, and the objective world is real and the subjective world is fantasy. We live in a world that is subjective. But there's some parts of this subjective world that have very low uncertainty associated with them, and other parts that have much higher uncertainty associated with them. You get the 5 accident reports because those 5 people have different levels of uncertainty about different things. How fast was the car going? That ran the stoplight. Well, somebody will say, oh, it was really speeding. And the other person will say, it's going about average. It really wasn't going that fast. 2 different perspectives. They both looked at the same thing, but they interpreted differently, you see. Well, which one's right? They both live in their own world. It's not a matter of right. All right, now you had a camera that actually measured the velocity of the car. Now you know exactly what it was, and you can state that as a number. It was going 45.3 miles per hour. Okay? But both individuals still saw it as about average, and another one is really fast. See? So the fact that the number is there isn't the point. The interpretations are always different. So that's a totally different way of seeing the world. Everything's subjective, some more or less uncertain. Now that takes the subjective things that have more uncertainty. It doesn't make them not real. Everything's real, you see, everything's subjective, it's all real. It just means that you have to deal with these things now statistically, because there's more uncertainty in it. That's why when you do a psychology experiment, or a sociology experiment, or a psychiatric experiment, what counts is the statistics. That's how we deal with things that are uncertain. We want to know, does this have a certain statistical reliability beyond the event happening just by chance? That's called statistical significance. See? So we apply more statistics to it. But it's all real, it's all important, and the most significant stuff is really the stuff that's subjective. And the least significant stuff is the stuff that's objective.
Well, I think that's one thing these scientists have decided has a value. Their therapy was enhanced by this particular method, this discovery of reincarnation. Dr. Jim Tucker, University of Virginia Psychiatry Department, experiments with children's past lives. And I think that has a value because children are more easily aware of things. As you've said at one time, they recall things and they're more in the other reality than we are.
They're less closed-minded than adults because they have not yet learned the way things are supposed to be. They haven't yet learned what's not acceptable. So more things are acceptable in their mind, things that they can't understand. Well, there's lots of things that children can't understand. So they kind of accept the world as a bigger place, whether they understand it or not. So they are more open. But they have one other advantage in studying past lives, and that is they have very little exposure to the kinds of things that would enable them to make up their past life experience. They don't have a lot of exposure to history, sociology, other things that would give them some idea of what it was like in the 1800s or the 1600s or the 1500s, if that's where their past life is. They don't really know a lot. You're dealing with a 6 or 7-year-old child. They haven't spent hours reading history books. They maybe can't even read yet. So you don't have to worry about that other variable, that it's something they read in a book or saw in a movie that they're just replaying now as a past life. These children have mainly watched cartoons and are not old enough to read, then they're not getting it from other sources. You can discount that variable, whereas an adult maybe has read books, has been through history classes, has some kind of sense about what the people would be wearing at a particular time in history and that kind of thing, that they could kind of make up and add details. But a 6-year-old, no way. If they describe what the people are wearing and it fits the era that they're in, then that's a lot more evidential than if an adult did that. You see, so children are really good candidates for this kind of research because they don't have the knowledge to draw from to fake it or to make it up.
What is the resistance that people have to reincarnation? For instance, Dr. Tucker received some comments on this University of Virginia magazine article saying that this kind of research perhaps shouldn't be allowed.
Yeah, how could a prestigious university like University of Virginia allow this kind of hocus pocus research to even take place? Well, that's the words of somebody who is very close-minded. That's the words of somebody who has beliefs. And in this case, it probably is religious belief, because in the East, Eastern theology includes past lives, includes reincarnation as something they accept. Western theology mostly does not, you see. So if you know that, then you kind of feel like, well, that Eastern theology isn't as good as mine. Those Buddhists aren't as good as the Christians as far as religion goes. If you're a Christian, you kind of discount that. That's what the heathens believe, not what good Christians believe. So you may have a tendency then, when somebody's doing this and finding reincarnation evidence, oh, that must be baloney, because it disagrees with my beliefs. So they can help. How could a university even allow that to go on? That's not real science. Couldn't be. Why not? Because they don't believe it could be. So it's just that. It's a closed-minded sort of thing, but you get a lot of that. Matter of fact, there are people who make careers out of being closed-minded. Except they don't call it closed-minded. They don't say, we're the champions of closed-mindedness. We refuse to think anything that isn't, that doesn't conform to the status quo. Instead, they call themselves skeptics. Oh, we're skeptics. We point out the truth, as long as that truth, substantiates our beliefs. We're really believers is what we are. We're not skeptics. We're true believers, and anything that conflicts with our belief, we will rail against and call it stupid and not scientific. But they rename themselves as skeptics, which is unfortunate, because being a skeptic is a very good thing. You should be skeptical. Everybody should be skeptical of everything. So that's unfortunate. But yes, there are legions of the closed-minded believers in every subject, whether they're fundamentalists, Christians, or fundamentalists any other religion, fundamentalist Buddhists or fundamentalist, Islam or anything else. They have the way, and anything that conflicts with that way is not only wrong, but very wrong and needs to be stopped. And these so-called skeptics are in that same boat. They are believers railing at other people that they call believers just because the second set of believers don't agree with them. They believe other things than they do. So it's back to the, belief wars is what's going on. So that's why there's just some person who believes what they're saying is rational. You see, people who are believers believe that they're rational, that their beliefs are truth. So when that person says, how can the University of Virginia let this kind of pseudoscience go on? They actually believe that. That makes sense to them. That sounds rational to them.
Contrary to all the evidence.
Yeah, contrary to all the evidence. Well, from their viewpoint, there can't be any real evidence because there can't be anything that violates their beliefs. So there is no evidence. And if you think there's evidence, well, you're just delusional. It's impossible that there is any evidence. And of course, that's not wrong. That's why scientists like this lady, like the guy you just talked about doing this research, like the psychiatrist we're talking about, these people are smart people, they're credentialed people, and the reason they pursue it is because there is real evidence. They've discovered the real evidence, they've experienced the real evidence, and they are good scientists and won't leave the truth alone. They have to go dig it out. We did a thing a few months ago about Rupert Sheldrake and his 10 beliefs, 10 scientific dogmas. Mm-hmm. And it's the same sort of thing. You see here, what happened? TED Talks tossed Rupert out for being, a pseudoscientist just because he violated their beliefs, their ideas, and they see themselves as skeptics, proud of it. Well, a real skeptic should be proud of it. Real skeptic is necessary. But these are, instead of pseudoscience, these are pseudo-skeptics. They're not really skeptical. They just have a contrary belief. They're fundamentalists is what really they should be called.
And Rupert Sheldrake's work has spanned 40 years, much like your experience. He had to pursue the discoveries, the truth from the discoveries that he made. It was as simple as that. If we could assign a value to the past life people we have been discussing, to their work, from a scientific viewpoint, I know you like to come from that viewpoint always, could learning from past life experience packets modify future probabilities?
Well, sure. You see, it's important. The work they do is important because whenever you start exploring these anomalies, things that you've found that you can't rationally dismiss them. When you find something like that, that's the most important thing in science, is to come up with evidence, if you will, that shows that this anomaly is a real anomaly. Because what that's done is it shows that the current model of reality is too small or wrong. I mean, that is the key thing in science, not just a conformity club. Everybody agrees with everybody. We're okay. We tell each other that. We don't see anything new. See nothing new, hear nothing. Hear nothing new, see nothing new, say nothing new. The three monkeys, right? That's not science. That's belief. So if you really want to do science, then you're looking for these anomalies. You find out that these anomalies have something to them. Then what else could be more important in science but to have these people doing this work? And it's not that they've done all the work and uncovered everything. What they've done is they've done enough research to show that it's interesting, to show that it's worth doing more research. All right, so typically you take a person like Rupert, and I've seen films of Rupert where he had a dog owner out and about somewhere doing something and the dog's lying there, and as soon as the dog owner decides to come home, the dog jumps up, starts looking out the window and this kind of stuff, and right to the second, right on the clock. And he's repeated this several times. Well, okay, that doesn't necessarily give us what we call good scientific data. What that shows is that looks like there's something real here, because he's done it, he's repeated it. It's not like it just was a fluke. Just as that person came home, it's just random chance that the dog got up, and he's done it enough times that the correlations in his data say that it's statistically significant that this was not random. There's something real going on here. All right, but that's just the beginning. You see, that's a scratch of the surface. What needs to be done is okay, we found an anomaly. We've shown that the anomaly has some substance. At least it looks like it does. We get statistical significance with this decent research. Now, let's just really explore it. Let's spend $1 million or 10 million on this subject and find out more about it. But see, that doesn't happen. What happens is, Rupert gets thrown out of TED Talks and everybody looks the other way. That's the problem. It's not that Rupert has proven everything beyond a shadow of a doubt. He hasn't. He's just shown that this is an interesting line of inquiry that holds promise, because he's done enough experiments to show that it's a promising line of inquiry. Now, where are the scientists stumbling over each other to get to this new anomaly and research it down to the last gnat's eyebrow and find out exactly what is going on? Is it just that dog, or is it every dog? Or do cats do the same thing? What about monkeys? What about rats and kangaroos? Is this something in the animal world? What about people? What about children? Research, research, research. Make science, better. And of course, because this is subjective, the research tends to be statistical. It's not that you can just do this once. You need to do this 100 times, 1,000 times under very strict protocols and develop the statistics. Why don't scientists jump on things like this, like this past life research of children? If you have a 6-year-old that claims to have been a pilot in World War I, and he can describe the aircraft, he knows the names, he maybe even tells you their own surname. Oh, I was Joe Jones, and you go back and you find out that sure enough in the RAF in World War I there was a Joe Jones, and he flew that plane, and he gives you maybe the serial number on the side of the plane, and it checks out, and you get all this data like that. Where are the scientists falling over each other to get to that and try to do something with it? You see, it's turned the other way. That's why I say real scientists. You got the real scientists who are out there trying to, find these anomalies and study them, and then you have the rest of science that are the technicians in science. They're the turning the crank, chug and plug, you turn the crank, you do the work, you find another nugget. Oh, you have a resonance here. Oh, you have a resonance there. How does this work? Measure this more accurately. But follow up these anomalies? Nobody's interested. Nobody would spend $1 to do that. In fact, how could the University of Virginia support such claptrap? You see, we want to take the money away from the people who are doing it. That's not science. That's anti-science. That's anti-science. These skeptics, they're not all about science. They pretend that they are the questioning arm of real science, but they're not. They're anti-science. We have real things here going on, and no, they're not done completely, just enough to show that there's something real going on here. Now let's find out.
I don't know why there's a conflict between materialists or mainstream scientists and scientists who have decided to go on and do research in reincarnation, like Dr. Bruce Lipton. He's a cellular biologist. He's discovered he's written the biology of belief and discovered many things that coincide with your MBT theory. Even Alexander, a neurosurgeon, became extremely ill with an incurable, technically incurable disease, and recovered from that.
He had an NDE, near-death experience.
He did have a near-death experience. And
big deal in his life.
Jill Bolt Taylor, a neurosurgeon who had
stroke.
A stroke it was. These people had these experiences happen to them and can never go back to the way they looked at things before. I don't see why there isn't respect for both groups. You have respect for the technicians and the material scientists that want to, as you say, there's a value to that work in the universities, plugging away, digging for nuggets and things like that. But there's also tremendous value in the work that these real scientists are doing.
Everything that shows promise, that there's enough evidence there to go on as, to study it further, science in general ought to jump on that. It's not that we want them to tolerate it. The question is, why don't they want to pursue it? You have PEAR Labs. PEAR Labs has been doing this research, like I say, for 30 years. Mainstream science turns their nose up at it and says, no, there must be something wrong. It's not that hard to do. If they found a major anomaly in the fundamental nature of reality, why hasn't every university on the planet tried to duplicate that work? Nobody wants to touch it. Nobody wants to see it. Nobody even wants to publish the paper because it violates their sense of reality. This is scientific belief, not science. And that is the problem. We don't have very many real scientists out there in the world doing work. It's only out on the fringe. Real scientists would make a stampede to these anomalous things, wanting to pursue them and find out how this works. They ought to all send an emissary to PEAR Labs. What is PEAR, after all? That's Princeton Engineering Anomalies Research. Princeton had the courage to say, hey, you found an anomaly here. Hey, you've measured it and shown that it's not just, it's not just random, that it's something you can control. You've done it over and over. That's important. Let's set up a group to study that. Princeton did that. Did anybody else follow along that line after it was real successful? No. Because nobody wants to get on the train that runs counter to the status quo belief. Nobody wants to go there. That's kind of why we're having that discussion. Real scientists you couldn't keep them away. They would have to do that. Here's something that shows that our whole sense of reality is probably inadequate. That's what the people who were doing the double slit experiment back in the early 1900s, they were all really excited. Wow, we really have found something new here. This is fantastic. We have things that show that the way we used to think of reality is just wrong. Reality doesn't work that way. And now, 90 years later, what's happened? We've denied mostly that even took place. I mean, we didn't deny it in fact, but the fact that they discovered something that was an anomaly in our reality. Same with the, it's not been that long ago that entanglement made the news. Entanglement shows that there's something very wrong or missing or inadequate about our model of reality. Then why do we stick to it? If we know there's something wrong with it, why not say, well, our reality doesn't work the way we think it does. Let's go explore these things. Maybe we can find out more about it. But that's not the idea. There's a few real scientists out there working their way toward bigger understandings, a bigger picture of reality, and then there's tens of thousands, if not millions of quote unquote scientists who basically blow them off and refuse to even look at it rather than run to it and want to do research in it. Why is that? Well, it's belief. It's just they are belief blinded. They're in a belief trap, and the trap won't let them think out of the box. And they not only don't think out of the box, they damn and laugh and ridicule anybody who does think out of the box.
That doesn't make any sense, because You said a while back, the things that are important to us are the things that are the intangible things, the love for one another, not pursuing the anomalies that are discovered is contradicting the things that are important to us.
Exactly.
It's contradictory to
It's contradictory to science.
Yes.
It is not, good scientists don't turn away from anomalies. They pursue them. It's contradictory to our self-interest. What's important in our world is our subjective life. Okay? A lot of these ideas, even the PEAR Labs, that mind can affect random number generators. What else can mind affect? Well, we know the placebo effect, right? Placebo effect is well known. We know intent affects reality. We know you tell a bunch of kids that they're not very smart, and you tell the teacher they're not very smart, they'll do a whole lot worse on standardized tests a few years later than a same randomly selected group of kids who are told that they're smart, and the teachers are told that they're smart. They'll do, their IQs will look like they're 7 or 10 points higher. Why is that? How do we do that? Well, we've measured it. We know that works. Mind affects reality. How is it? Could that be important to us? What else could be more important, right? A minor resonance, with a $100 billion, atomic collider? What could be more important to us than these kinds of questions? And what does science do about it? What does these mainstream science do about it? They turn the other way, pretend it doesn't exist, and go on with their picks and shovels, digging out nuggets. And again, it's not to disparage the importance of digging out the nuggets. That's good. But geez, that's not what science is about. You need people to do that, but you'd think that these other fields should be worked and worked very heavily. So if somebody comes out with a theory, like myself and my big toe, and it seems to make sense, and it answers questions in science, it's better physics, it answers questions in theology, it answers questions in philosophy, it pulls everything together, it builds a scientific foundation under Weiss, under PEAR Labs, under these other people that you mentioned. Now there's a consistent, logical foundation to put what they're doing in a context. And where are all the scientists running to, experiment and see if they can't prove or disprove it? Nowhere. You see, they basically are not interested in going there. So it's a product of our culture, our way of thinking. It's a low quality in consciousness. It has to do with fear. People are afraid to go boldly where no man has gone before. That's terrifying. And most people are not the Star Trek crew. Most people cower from the idea of going boldly where no man has gone before. They say, well, I kind of like the status quo. My career's built in the status quo. I don't want to go boldly where no man's gone before. I want to stay home and, dig out my nuggets and leave me alone. No, thank you. I don't want to go there. Well, there's a problem with that. It's fear. That's why we don't go. And the fear creates ego. And the ego creates, I'm right, you're wrong. I don't have to look at your work because I know you're wrong because it conflicts with my beliefs. So that's the unfortunate thing. But it's always been that way. Take a look at any field. Right now we're just talking about science. Take a look at any field. Not just science, but any other field, and you'll find it's exactly the same way. The new ideas, the new understandings, the breakthroughs all come from the fringe. The center is all frightened and mainly interested in upholding the status quo, and it's belief blindness on their part. They're in belief traps and can't look through it because the quality of their consciousness just isn't enough yet to let them break out of those kinds of beliefs. They're too frightened, too much fear. So that's the thing. We say, well, it's rational. You say, it doesn't make sense, Why? And that's why. Fear. Fear is the problem. Fear is why we have fundamentalists. Fear is why we have belief traps. Fear is the thing that holds everybody there. So don't expect a rational explanation of why. Rationally, it doesn't make sense. Rationally, scientists should mob a new anomaly that's shown to have promise, like these have. There's enough evidence here to show that it's worth studying further. But they fear that sort of thing, and it's not a rational thing. Fear is never rational. You cannot fight fear with rational discussion. You see, if there's somebody's afraid and they're terrified, and you rationally try to tell them, oh, it's okay, sweetheart, there isn't any boogeyman under the bed, there's no monster hiding in your closet, it just doesn't help. You see, you can tell them that, but it just doesn't help. They're still terrified just the same. So we're sitting here having this discussion, and you're asking, why? Why? This is not rational. It doesn't make any sense. It never does. Fear is not rational. Fear does not make any sense, and you cannot rationally explain away fear to somebody. If they're afraid that there is a monster in the closet, you telling them that it's not there, even if you go look in the closet and say, well, look, I'll go look in the closet, and okay, there's no monster in here. Good night, sleep tight. It doesn't matter. They're still afraid. You see, it's irrational. And the skeptics who are out thinking they're champions of science, they're champions of fear. They're champions of belief. They're certainly not champions of science. They're anti-science. There isn't any more anti-science than what the professional skeptics do. Throwing Rupert Sheldrake out of the TED Talks, that's anti-science. That's the antithesis of science.
Now, astrophysicist Dr. Bernard Haisch, there are a couple of, he's astrophysicist, Dr. William Tiller, Professor Emeritus, Stanford. They've done models of reality and have pursued what they feel is...
They've done experiments and pursued anomalous findings, found that there's something really there. I remember seeing on YouTube, Tiller had a man raising and lowering pH with his intent, and he had all of that on film, and it was a very strong case. So did the great mass of scientists want to go do that and verify it? Well, partly because it has strong subjective components. It's a little harder to do because you have to do it many times and keep statistics. And because it's subjective, not everybody can do it the same. So this old part of the scientific method, which says anybody should be able to do any experiment, any place, and get the same result. That's true if the uncertainties are very small. As long as you're dealing with this part of the subjective world where the uncertainty is small, that part we call the objective world, then that's approximately true. You can do pretty much anything, anywhere, at any time, and it comes out the same way. But where you're dealing with subjective components that have a fair amount of uncertainty, that's not true. Not everybody at PEAR Labs can sit down and make the same sort of modification in a random number generator. Some people are much better at it than others. Some people are better at it some parts of the day than others. Sometimes they're really good at it and sometimes they're not. You see, this requires statistical research. This requires training. It's not a simple thing to do. It's not like you pick up a rock and you weigh it. Everybody picks up that rock, weighs it, gets within plus or minus a certain amount of error, the same answer. Everybody that tries to use their intent to modify a random number generator doesn't get the same result. So that's because everybody's consciousness and their control thereof is not the same. Most people have such noisy minds. They have so much ego and fear running around in their minds that their intent is very weak and unfocused. Well, those people don't affect things very much. Their mind isn't capable of it. Somebody whose mind is not full of noise can have a much bigger effect. So it can't be done by anyone, anytime. People are different, you see. So that old rule in our scientific methods that anything can be done anywhere by anybody and it should be the same only applies to that small and relatively insignificant part of our reality that we call the objective world. That doesn't mean that in the subjective world you can't do science. You can do science in the objective world. It's just more trouble. And if you want to experience it, you may have to spend 6 months or 6 years learning to quiet your mind. If you want to be able to modify a random number generator successfully, you may have to work at it. You may have to train to do that. But you can. If you take the time, you can learn to heal someone. You can learn to remote view. You can learn to go look at past lives. You can learn all these things, but it's not open to everybody, anytime, anywhere. That's the difference. So we expect that, though. As our science grows and gets bigger and broader, so we're understanding more and more, it generally gets harder at the same time. We've got more variables we need to control. We've got more difficult ways we have to do the science. And now we may have to do it 1,000 times to get good statistics over what we're doing. So it gets harder. But just because it gets harder isn't any reason to ignore it. It still can be done. We can still do good science in the subjective realm, just as good science as we can do in the objective realm. It's like, just let's go do it, right? Let's not deny that it exists. So that's the kind of the problem in a nutshell. It's been a pretty big nutshell here for the last half hour or so. But anyway, that's kind of the science problem that we have today, and the skeptic problem we have today. The skeptics aren't skeptical is the problem. The skeptics are believers. They're only skeptic. They call themselves skeptics because they're skeptical of people who don't believe the same things they do. Well, that's not really being skeptical. That's being a fundamentalist, a fundamental believer.
Another highly credentialed physicist, Dr. Russell Targ, pioneered research in lasers and optics, legendary for his remote viewing protocol. When we say remote viewing, we're talking about it's a proven perception discipline for gaining information, not usually available to the ordinary.
Yeah. Or we could
senses.
just use that dreaded word, paranormally, right? Getting information.
I was trying to avoid that one.
Yeah, I noticed you were struggling there, but that's true, and we don't like to say that because paranormal, well, that doesn't exist, you see? You call it paranormal, you might as well call it bogus. And we have to get over that. Paranormal just means it's an anomaly. It doesn't fit into our present sense of how reality works. Well, geez, that's a call to arms to real scientists to go find out. That's not something to avoid like the plague, but because the traditional or the middle, of science, the mass of scientists, because they're not really good scientists in that sense. They're good at digging out the nuggets, but they're not really big. They're not big picture people. You have to kind of weasel word around that paranormal, otherwise you get branded as a flaky woo-woo person of no consequence, and it's very unfortunate. Anything that's anomalous, which means outside the normal, ought to be a magnet to real scientists. They should be all over it.
And yet, Dr. Targ, co-created the Cold War spy program that became the Real X-Files. It seemed to be rather successful there.
Yeah.
And many successful remote viewers, we don't want to leave any profession out, were our engineers. So these things have been proven to be very successful. And again, that's on the fringe.
So there's a lot of science that's been done in remote viewing, lots of it. Go Google remote viewing and remote viewing experiments, and you'll find that they've got some of the most severe protocols of any science anywhere. They've done really good science with it, and well, has anybody proved that remote viewing really works? If you ask that question, it shows that you really haven't made any effort whatsoever to answer it. That's a question that you can only say if you're a believer. Anybody who's spent some time in the remote viewing world realizes it's been shown tens of thousands of times that it really works under immaculate protocols. So that's not really a question. It's a question of how does it work? Why does it work? Why are some people better than others? And then, of course, if you have a My Big Toe to look at, you can answer all of those questions. You see what the structure is and what's going on, and that you're actually plucking plucking information out of a database is how it works, and that the database is a logical consequence of the nature of this virtual reality. The database is required. Same with the modifying random distributions at PEAR Labs. That has to do with intent modifying future probability. It's the same thing that makes the placebo effect work. It's intent modifying future probability. So now that there's a structure under those things, I would hope that they would get more scientific attention, because there's a context, a plan, a theory, underneath of them to work on, to try to disprove. And maybe they will. Maybe we'll get more attention in these things now, but I don't see a crowd rushing to do it.
Your My Big Toe theory is logically derived. And not to leave out the mathematicians, but Brian Whitworth and John Ringland have both shown that the logic that's in your My Big Toe theory is workable in mathematical calculations in different ways. Yes,
and I would add several others to that. Wolfram in in that work with cellular automata has done something similar, and also Edward Fredkin has also done a lot of work in cellular automata that has also done the same thing. And Fredkin's work was interesting, and I think they showed the same result. He came up to the same conclusion, and that is that a cellular automata can be configured to be able to produce any calculation or the same results as a general purpose computer. So that means the cellular automata, now for those of you who don't know what that is, that's if you just have cells and they're simply, they're a 1 or a 0, a black or a white or something like that. And then you have a little rule about how they can change from 1s to 0s, how you change those things. That's a cellular automata. Then you run the rule, and as you change the rule, the patterns of 1s and 0s and blacks and whites change. And go to the web and look up Game of Life, and you'll get it. And they'll give you some basics of cellular automata. But anyways, these cellular automata of certain sorts, they're still just simple systems with simple rules, and they can create the logic required to do general computing. Well, once you can do general computing in a digital information system like consciousness, that's the same as saying you can do anything. There isn't anything you can't do. Can you build a virtual reality like this one? Sure. You can do it in a general computer, general purpose computer, digital computer. So cellular automata support this idea that you can evolve a potential that's very simple, with a very simple little rule set and a little simple 1 and 0. It can evolve to become a general purpose computer. And also John Ringland, it's a name most of you probably don't know, you can look him up. He presented, basically a mathematical sets of equations that you can use to simulate anything else. So you start with a little bit of logic, some rules, some math, and you end up with just a small set of linear, I think, equations that can be used to describe everything. Again, general purpose computer. You can describe everything else. And all what I have said in my model, when I get the question, well, where does consciousness come from, is that it starts, and this is the assumption of my model, as just something simple. It doesn't start as what we think of as conscious today. It is just a self-modifying system. Well, that's not too remarkable. Lots of systems are self-modifying. Cellular automata are all self-modifying. They have rules and they change themselves as they iterate, through their rules. So it's a self-modifying system that could differentiate a 1 from a 0, a yes from a no, 2 states. And that's all you need. If you just have that potential to do that, evolution can take care of the rest, to where you have the larger consciousness system that we think of it today with virtual realities and all this, complex work. That's all you need. It's a logical derivation. You can't get the larger consciousness system unless you start with this potential. That's why I just started with it as an assumption, because you can't get the B if you don't start with A. And what John Ringland and Wolfram and Dr. Fredkin have all pointed out, you can get from A to B mathematically. Logic says you have to get, if you start with A, you can evolve to B. That's just a logical process, and it's there. But they do the mathematics that show how that actually can work. And now on the back end of it, we have Brian Whitworth, who brings, and I wouldn't say mathematics so much, although computer science is sort of math-based in its own way, but he takes simple computer science processes, okay? Simple processes of computation, and from those, he says that you have this thing he calls a Planck process, which is his simple, basic process. And with maybe 2 or 3 assumptions, not much, just a very sparse number of assumptions, he can show you how these simple Planck processes can derive our rule set. Everything that the rule set that basically creates evolves, creates our virtual reality. Virtual realities are based on rule sets. And Brian can show that you start with this Planck process and a couple of rules that are simple, little rules, nothing really complicated, something that you can write down in an inch worth of paper. And from that, you can derive this virtual reality. All the rules that show you how this virtual reality works. So you got the front end being able to show the mathematically how you can get from a 1 and a 0 and a system that can change itself that's evolving into the larger conscious system. And on the other end, you have mathematics, or computer science at least, to show how the rule set could have been evolved out of simple processes. So, on both ends, math has been applied to come to a solution that, sure, this could be done. Look, I'll show you. Yeah, just work the math. Just work the process, and you can see how it works out logically. So could the larger consciousness system evolve this way? Sure. Can you prove that? Sure. You see? But logically, we know that it did because we're here, right? So we already have that as a known. We're here, we're conscious, and it's easy to trace back where that had to start. Darwin had the same problem. He looked around and he said, well, we're here. We've got all these animals and bugs and everything and even trees and plants and everything. We're here. How do you logically trace that back to the most simple, step in the beginning? What do you need to begin this? All you need's a cell. You see, you need that first cell, or those first cells, if you will. And after that, the logic of evolution derives everything else. But you start with that first cell. So it's the same thing. Because we're here, we know we had to come from somewhere. How can you keep taking it back to make it simpler, 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 simpler? How far can you go? Well, in biology, you can go all the way back to the first few cells, or even the first cell. That's where you have to stop. You can't take it back any further than that. And in consciousness, you take it back to that potential that was a self-changing system with a 1 and a 0. That's all you need. From there, all the rest is logical. It's all doable. And now, of course, we have math on both ends that shows that, yes, and it not only is it doable, but here is a process that does it. Now, Ringland's process and Wolfram-Fredkin process are totally different. So what it says is that there's not just one process that'll take you there. There's multiple processes that'll take you there. They're different approaches entirely, you see. It doesn't really matter. So what was the real process that the system, of consciousness really, it doesn't matter for one. We know that it can get from A to B, that's enough. How did it get there? Maybe a little bit of both, maybe all of one, all of the other, who knows? And maybe there's 5 other ways to get from A to B. Those 2 aren't necessarily the only 2. There may be other ways that you get there. And what did this system actually do? It's hard to say, but really it doesn't matter. We know that there is a way that you can chug your way logically, mathematically, from A to B. That's all it takes. And there's a logical way that you can take a simple Planck process, as Brian describes it, and create the rule set that creates this virtual reality. So those have been shown, we'll say derived mathematically, but what they've actually done is they've just shown that it's possible to go from A to B, to go from just a couple of, the simple thing you start with a 1 and a 0 to a larger consciousness system, or to go from a single cell up to all the life forms that are on the planet. It's a logical process. So yeah, that's been done. So the front end and back end of the theory are kind of demonstrated, if you will, mathematically. And what's in the middle is demonstrated logically. I mean, because it goes through these steps. We're talking about reincarnation. As it goes through its logical steps, which I lay out in my book, one of those steps, which is a logical requirement of the process, is that there is such a thing as reincarnation. Okay? Otherwise, the system doesn't work. You see, that's a logical requirement. Now, in my books, I don't call it reincarnation because I wanted to get away from that. That's a religious thing, right? That's what the people in the East believe, and we smart people who really know the truth, we don't believe that. I didn't want to get into that kind of a fight, so I called it experience packets. It takes multiple experience packets for an individuated unit of consciousness to grow up. It's not something you do quickly. You have to have part of the logical process, otherwise the model doesn't work. So this reincarnation or multiple experience packets is a logical necessity of the model, of the process. But now you go logically on downstream from that, okay? And you have more logical processes like a future probability database and the past databases. Those are logically required in order to produce the virtual reality that we call our physical universe. So they're logical necessities. And then you take the next couple of steps down the logic chain and you can understand how the double slit experiment works. You know exactly how it works. It's not that looking at it causes it to become physical. That's not it. It's about probability. Everything is just probable in the probable future until it becomes into the present. And it comes into the present by showing up in somebody's data stream. You see? That means we call that making a measurement. So we get this wrong idea that looking at it makes it, creates it. That's not it. It's not the way it works. It's probable until that fact gets sent to somebody's data stream, then it becomes a reality for that individual. And because this is a multiplayer game, what's a reality for one individual needs to be reality for everybody. It needs to be reality for other individuals here. They need to see the same things. One can't see one thing. One can't say, I'm sitting in a chair. Another one say, I'm sitting on a stool. Somebody else says, I'm standing up in a field, you know. No, you know, we all have to agree I'm sitting here in a chair because this is a player reality, and we have to agree on these things. So that it would be inconsistent, and there would be a conflict if people found different realities when the uncertainty is small. Now, if the uncertainty is big, we can see different realities and it's okay. But when the uncertainty is really small like this, we can't. That's not allowed. So everybody has to get the same thing. So anyway, it does that, and it tells you, you know, about entanglement. Why does entanglement work? Well, it just flows right out of this theory. So if you can explain entanglement, the speed of light being constant, double slit experiments, and that's on the very end of the logic stream. Well, that gives me confidence that the logic stream is right, because you start with something, you evolve it to a larger conscious system, mathematically verified. Then you have these logical components that you have to have, and eventually on the end of all of that, in our physical virtual reality, you have, you know, what we call physics, and it does better physics than physics. So that gives me confidence that the logical process is good. It would be hard to have something that was not right, not logical, that wasn't, you know, correct in this chain of logic, and then end up with the right answer at the end. Not impossible, you know. You could have two logical errors and one fixes the other, but that's not the way this works. This is not a real complex logic problem. It's a very simple, if this, then that. If that, then this other thing. If the other thing, then this. And there's about 4 or 5 steps in it, and at the end, you do better physics. So those 4 or 5 steps in that process are probably right if they're necessary to that process. So that's why, you know, the reincarnation thing, the experience packets, it's a logical necessity to the overall theory. It's not like that's something I just added in because I believed in it, you see. It's a logical, necessary step in this process to better physics. And not only that, it's better theology. It's better psychology. You know, it answers all sorts of things. You know, we understand now what these ancient sages were saying when they were talking about the world. You know, was not fundamental. It was maya. And we know what they mean about love. What's the words? God is love, right? Love is the answer. We're here this is a learning lab. We're here to grow up. You know, now we can put that in a context. That mind affects future probability. Well, that's just, again, that's part of the logical construct to this system. So there's PEAR Labs. There we've got Brian Weiss. You know, all these, we've got Bill Tiller with this person raising and lowering pH. All of this can easily be explained once you have this bigger picture. So suddenly there's a theory that builds a scientific foundation under all these weird paranormal anomalies that fly in the face of our traditional view of reality.
And that's my big toe.
And that's basically my big toe. And that's kind of the value of it, is that it pulls things together. It gives a basis under everything. And I've had any number of people write me with the basic idea of, I've had all these strange experiences. I knew they were real, but I didn't have any way to pull them together. It was just weird experiences that I had. So I couldn't talk about them to anybody. I couldn't even make sense of them in my own mind, other than that I had them. And sometimes I even thought maybe I was going insane. And then suddenly I read my big toe and, oh, they're just normal experiences. You know, they fit right in. Here's a science that includes my experiences as a normal and natural part of the way the world works. And that's a very big relief to a lot of people. Well, it does that to PEAR Labs, it does that to Brian Weiss, it does that to Mr. was it Kuhn. It basically builds a scientific basis, a foundation under all of these, say the awful word, paranormal experiences. It builds a foundation under Rupert Sheldrake. You know, why would that dog be able to do that? How could that dog know his master's coming home? Well, that's easy. All consciousness is netted. It's a conscience. You know, the dog is conscious. You know, the person is conscious. Consciousness is netted. It communicates. That's what consciousness does. It's an information system. It doesn't do anything else but that. It communicates. It interacts. It passes information back and forth. That's what a consciousness system does. And it has to do with intent and focus. And we can explain, well, how come the human doesn't know? The human's got all this noise and chatter. The human has this big intellect, and this big intellect gets in the way. It judges everything and analyzes and has beliefs, just like these skeptics. You know, they think they are scientists and they're actually just believers. And they have these beliefs that get in the way because data comes in that's contrary to the belief. You just short circuit it, you know, you deny it, you let it go, you don't deal with it. So people have a problem. Yes, could people do this just like the dog? Sure, some people do, but it's called paranormal. We don't want to think that our dogs are all paranormal. You know, that doesn't work, but they're not. They're just normal. Once you understand how reality works and consciousness works, it's all just normal. The work that's done at PEAR Labs is just normal. You know, the placebo effect is just normal. Telepathy is normal. These past life regressions that they actually help people and that they're good psychiatric tools, this is normal. This makes sense. It's all part of the same thing that does better physics. So that's, you know, that's kind of where I am, I guess, in this whole thing. I'm always disappointed by the lack of interest by mainstream science in these things, but that's been that way all my life. So it's not a surprise to me. I don't expect that because the average person, including the average quote scientist unquote, is frightened, is very fearful, and very much afraid to go boldly where no man has gone before. You know, that's terrifying. And it also is bad for the career and it's full of uncertainty. How can I pay my mortgage every month based on what might happen? I need to have something that I can guarantee will happen. So I feel safe in this center ground with everybody else who's with the rest of the herd that's conforming to feel safe. So if you're one cow mooing in the middle of the herd, you feel very safe. And that's the way most of us are. And right now we're just pinning that rap on the scientists, but you could pin that same rap on anybody else in any other field of study anywhere. It's not just the scientists. That's just the way we human beings tend to react. We tend to be fearful and full of ego. So we are afraid to go boldly anywhere. Certainly not where no man has gone before, and we are afraid to admit that we're wrong, and we're afraid to admit that what we based our life on maybe has holes in it, and it's not as good a view of reality as we thought, even though for 90 years our quantum physics has told us that this reality that you think you have, that's this physical, objective reality, it doesn't really exist. We've known that intellectually for 90 years, but emotionally, we haven't yet been able to get there, get over it. We're too fearful to take that step and actually admit that at the emotional level. Yeah, all the quantum physicists admit it at an intellectual level. Sure enough, our reality just isn't like we thought. It's weird, weird physics. But at the emotional level, it's still this materialist universe that works exactly like clockwork, just like Newton said. We're still Newtonians at heart, and at the gut level, We're still in the Newtonian era. We haven't yet made it out of that emotionally. Intellectually, yes, but emotionally, not many of us. Just the ones on the fringe who dare to go beyond the safe, herd at the center.
Well, all of the scientists who we have mentioned here today have contributed greatly to understanding of the larger reality. And you, Tom, your My Big Toe theory supports them all. So I thank you. Thank you to those real scientists, and thank you to you for today.
You're welcome, Donna. Thank you for arranging this and asking the very interesting questions, as you always do.
Thank you.